Hello students. Now we're going to discuss about the Maxwell's equations and also electromagnetic waves. So this is very important topic for engineering and why we have to study this electromagnetic waves. So we are all enjoying the electronic gadgets, right? So without this, the Maxwell's equations, we cannot understand the concept behind the electromagnetic fields. Okay, so first, what is an electromagnetic waves? So the electromagnetic is the subject that we deals with the theory and applications of electric and magnetic fields. So the concept of electromagnetics is the prime importance in almost all fields of engineering, especially electromagnetic communication, which will perform the foundation, which forms the foundation of mobile communication, satellite communication, optical fiber communication. So, in all these applications, like electric magnetic field properties are utilized to transfer the information. So we have n number of applications. We are all enjoying with these applications. The one is electricity generator, Xerox machine, printer, cathode ray oscilloscope, ammeter, voltmeter, speaker, etc., etc. Okay, so to understand these concepts, we have to know that. So first one is Maxwell's equations. This will plays a very important role to understand the electromagnetic fields. Okay, to understand this, first Maxwell's equations, we have to know that first basic concepts. That is the one is the fundamentals of vector calculus. So what is this? So the one is the um, vector calculus is mainly physical quantities and which can be divided into two types. One is the scalars, another one is the vectors. So these are the fundamentals of vector calculus. Now what is a scalar? You all know that a scalar, which is a quantity which measures only the magnitude, and the vector represents or which measures both magnitude and the direction. So you know the examples. The example for scalars are temperature, mass, time, etc. And the example for vectors are like the vector fields like velocity, acceleration, force, field strength, etc. You have already studied this in a PUC, but once again we'll recall this scalars and the vectors. And all these quantities which have a magnitude and the directions are not vectors. This you have to keep it in a mind. Okay. So, for instance, the electric current has a magnitude and a direction, yet it is not a vector quantity, as it does not obey the parallelogram law of addition. So, next is a scalar product or a dot product. So, what is a scalar product or a dot product? So, you know this diagram. So, we'll consider two vectors, okay, A and B. So the angle between A and B is theta. So the what is the scalar product of these two? So scalar product of two vectors, it is defined as the product of magnitude of the two vectors and the cosine of the a smaller angle between the two vectors. Okay, and it is represented by a dot between the vectors. So it is called as dot product. So dot product is, see, the equation A dot B equal to the magnitude of A vector and the magnitude of B vector into the cosine of the angle between the two vectors. And this is known as the scalar product or a vector, scalar product or a dot product. Okay. Next, by seeing the diagram, you can tell that it is a vector product or a cross product. So, vector product or a cross product, it is defined as the vector having a magnitude equal to the product of the magnitude of the two vectors and the sign of the angle between the two vectors and the direction perpendicular to the plane containing the two vectors. So you can see the diagram here. These are the two vectors A and B. So these are product of these two vectors. The angle between these two is theta. The sine of the angle between these two, that is sine theta, and vector product of A and B. So we can represent an equation that A cross B will be equal to A dot B sine theta. So this is the cross product or a vector product. So in a three-dimension way, if you want to write, so we can write the equation like this: A cross B, the vector A cross vector B will be equal to I, J, K unit vectors Ax, Ay, Az, that is X direction, Y direction, Z direction, A vector, okay. So in three dimension it is considered, and a B vector Bx, By, Bz. So we can write an equation that is for a cross product like this, okay. And next is vector operation. So what is vector operation? It is denoted by the symbol del. So del is a vector differential operator and it is represented by the symbol lambda. Okay. So whenever applied to a function which is defined on one dimensional domain, and it is denoted or denotes its standard derivatives as defined in the calculus. Okay. So this is about the vector operation. So the vector operation we can also called as the curl. So the curl is nothing but the rotation. So it is denoted by this equation where lambda is equal to dou by dou x into a cap x plus dou by dou y into a cap y plus dou by dou z into a z. Okay. Next, what are the physical significance? So the physical significance are very simple. The cross product is put forward in mathematicals uh, and could be applied in physics under suitable circumstances. For rotating a body, the moment of a body, which is linear moment, is the angular moment. The angular moment acts in a direction perpendicular to the momentum and the radius vector. So the angular momentum is denoted by the symbol L, is given by the cross product of a radius vector R, and the linear momentum is P, so that we can write an equation where vector L equal to vector R cross vector P. So this is the physical significance of the curl. So what is the del operators? So del operator, where del can be written as like I cap into dou by dou x plus j into dou by dou y plus k into dou by dou z. So this is an operation which can be applied on scalar quantities that results in a vector quantity. Okay. So the del operators on a scalar function delta t called the gradient, on the vector function via the dot product del dot a called as divergence, on vector function via the cross product del cross a called a curl. So these are the basic concepts under. Next is like gradient. So what is a gradient? So consider a del product, that is the operator del acting on a scalar function. So del v equal to I into dou v by dou x plus j into dou v by dou y plus k into dou v by dou z. So the gradient del v points along the maximum variation of the function v, and the magnitude of delta v gives the rate of change in the maximal direction. That is the gradient. These are the physical significance.